Hello everyone, welcome back to the channel. It is your favorite laid-back host Nino, broadcasting right to your screens and headphones. Today is Tuesday, the 10th of March, 2026. I'm super pumped to be hanging out today, just talking to myself and you all. And I am introducing a trending article from the archives. Before we get too deep into the heavy stuff, I have a very important question for you. Why did the spreadsheet go to therapy? Because it had too many unresolved cell issues. I know, that joke was absolutely terrible. And no one ever gets my spreadsheet humor. But I find myself hilarious, so I'm going to keep making them anyway. Let's get right into the meat of today's video. The title is Beyond Rows to Reasoning Agentic Retrieval for Multimodal Spreadsheet Understanding and Editing. The goal is Chat C, Ogway 4603.6500 is long. Let me break down what this massive and frankly mind-blowing paper is all about, and why it is honestly super cool for the future of artificial intelligence. So, think about how we use large language models right now, especially when we want them to look at corporate data. Usually, if you have a really big enterprise spreadsheet, it is a total nightmare for the AI to understand. These real-world spreadsheets are not just simple tables. They have millions of cells. They have cross-sheet dependencies where one formula references another tab. And they even have embedded visual artifacts like charts and images. The core problem that this paper is trying to solve is that cardinal methods absolutely stink at handling this kind of messy, giant data structure. Right now, there are basically two main ways researchers try to fix this issue. One is called compression basement. This is where they try to squeeze the spreadsheet down, removing empty spaces and squishing the data, so it fits in with the limited context window of the AI brain. But the problem there is that you lose a ton of important data resolution, and the AI misses the fine details. The other way is called single-pass retrieval. This is where the AI tries to search the document once, grabs whatever chunks of data thinks are relevant, and then tries to answer your question. If I'm looking for a specific financial number, I do not just search once and give up if I cannot find it. I check one sheet. I follow a formula to another sheet. I look at a bar chart, and I gather evidence incrementally, step by step. Core AI pipelines cannot do this, because the language model lacks the ability to requery, explore adjacent regions, or refine its search based on intermediate results. It is forced to make a guess based on that first single pass. This brings us to the hero of our story today, a brand new framework called BRTR, which stands for Beyond Rows to Reasoning. This system is absolutely brilliant, because it completely replaces that old single-pass search with what they call an iterative tool calling loop. What does that mean in plain English, you ask? Well, it means it acts like an autonomous agent. It is given a set of 5 structured search tools. It can search rows. It can search columns. It can search rectangular windows of cells. And it can even search embedded images. When you ask it a complex question, it does an initial search, looks at the results, and then actually thinks to itself, this is not quite enough information yet. It goes back and searches again. Maybe this time it applies coordinate filtering, looking for a specific column it just learned about. Or checking a different tab in the workbook. It keeps doing this in a loop, but to 50 times if it needs to, until it has gathered enough solid evidence to give you a perfect answer. This is a massive leap forward compared to older technologies. For example, if we compare it to a baseline called Spreadsheet, which just tries to compress the whole workbook, BRTR completely blows it out of the water. When workbooks get really complicated with cross-sheet references, the compression methods just fall apart, and if you try an full context injection, which is basically just shoving the entire unstructured file directly into the AI prompt, AI just runs out of memory beyond 50,000 cells and crashes. BRTR is so smart, because it uses a very clever context budgeting mechanism, as it searches and accumulates data, especially heavy things like base 64 encoded images, The conversation context grows fast to prevent context overflow. It applies an analyst prune strategy. Whenever new images are retrieved, it actually strips out the heavy image derivative from its older searches, keeping only the text metadata like the sheet name and alt text. This means the AI never gets overwhelmed by too much data, but it still remembers what it saw. That is honestly so clever. The researchers put this framework through its paces with over 200 hours of expert human evaluation. They started by testing 5 different multimodal embedding models, just to see which one was best at understanding mixed text and visual data. They found that the NVIDIA NeMo Retriever 1 billion parameter was the absolute top performer. It had the highest recall, meaning it was the best at finding the right chunks of data. This is great advice for practitioners out there who do not know which model to use. They evaluated the whole BRTR framework across 9 different large language models. The results are just staggering. And a really tough benchmark called FortreBench, which is massive enterprise workbooks. Top-tier models like Gike 5 and Gemini 3 Pro achieved a mind-blowing 99% accuracy. That is an improvement of 25 percentage points over the previous best single-pass method. It is just wild how much better the AI gets when you let it search multiple times to refine its understanding. But they did not stop there. Oh no. They wanted to see if this could handle complete enterprise workflows. So they built a planner and executive architecture into BRTR. Instead of just answering questions, the system can actually plan out multi-step workflows. It takes a big complex instruction, breaks it down into a dependency graph of smaller subtasks, and hands them off to specialized executors. There are 6 of these executors. There is an Excel executor for reading and writing cells, an IO executor for handling puffs and Word documents, a web executor for fetching financial data from the internet, and a validation executor to make sure accounting and variance actually hold true. They tested this on the Finch Finance and Accounting benchmark, which involves massive tasks across thousands of spreadsheets. The Opus 4.6 achieved over 95% accuracy, which is an insane 48 percentage point jump over naive single-call agents. In the ablation experiments, they proved that this planner is absolutely essential, without the planner decomposing the tasks. A single monolithic AI agent used 40% more tokens, and its accuracy dropped by 20 percentage points, because it just got confused trying to do everything at once. Let us talk about how this amazing technology actually applies to everyday life. I'll give you 3 specific application examples based on the content of this paper. The first specific application is in corporate auditing and financial compliance. Imagine a big accounting firm trying to audit a massive multinational corporation. They usually have to cross-reference thousands of incredibly messy spreadsheets, along with PEF receipts and scanned invoices. With BRTR, an AI agent could automatically navigate through all these heterogeneous documents. It would look at a final consolidated balance sheet, realize it needs to verify a specific travel expense, use its search tools to dig into a different department of the spreadsheet, find the transaction, and then use its optical character recognition executive to read a scanned original hotel receipt. The impact here is absolutely huge. It turns a painstaking manual process that takes human auditors weeks to complete into an automated workflow that takes minutes. And because BRTR maintains explicit tool call traces, human auditors can see exactly how the AI found the answer, ensuring full auditability and trust in the real world. The second specific application example is small business inventory and supply chain management. A lot of small business owners run their entire operations on messy, disconnected spreadsheets. They'd have one sheet for warehouse inventory, another sheet for vendor orders, and maybe exported files from a point-of-sale system. If an owner wants to know why they all run low on a specific part, BRTR could act as their personal autonomous logistics manager. The planner would break down the diagnostic task, or would use the search executor to find the part number in the inventory sheet, cross-reference it with the sales sheet to see if there was a sudden spike in customer demand, and then check the web executor to see if there are known shipping delays from that specific supplier. You could use the Excel executive to generate a brand new formatted report with a chart showing the inventory trend. This would save everyday business owners so much time and stress, giving them enterprise-level data analysis capabilities without needing to hire an expensive data science team. The third specific application example is personal finance and tax preparation for everyday people. Think about tax season, which is a massive headache for pretty much everyone. You have your official tax forms in puff format, a very messy spreadsheet where you try to track your freelance income, and random images of business lunch receipts. You could just hand all of this unstructured mess to a personal finance assistant powered by BRTR. The planner would break down your tax preparation into logical step-by-step subtasks. With your messy income tracking spreadsheet, use its iterative search to find any missing months or anomalies. Pull the official numbers from the PEF forms using the IO executive, and then use its Excel executive to format a brand new perfectly calculated tax summary workbook. The impact here would be life-changing for freelancers and gig workers. It would make tax compliance completely painless, ensure no legal deductions are missed, and totally democratize access to high-quality financial structuring that was previously only available to people who could afford personal accountants. This paper is really pushing the boundaries of what artificial intelligence can do with structured enterprise data. It is not just about passively reading rows of text anymore. It is about actual agentic reasoning, iterative problem solving, and letting the AI explore the data down the line, exactly like a human professional would. The fact that it can safely write formulas, create charts, and validate complex data across so many different file types is just so incredibly exciting for the future of work. That is all the time I have for today on the radio. I hope you found this deep dive as fascinating as I did. Make sure you check out the full paper if you are a huge data nut like me. Have a great rest of your Tuesday. Stay laid back, and I will catch you in the next broadcast. Bye now.